Good afternoon, ladies and gentlemen. So this is the closing session of the day. Through all the day, we have been speaking about living in a sustainable world. You know today that most of us, 70% of the population, are living in cities, are living in buildings, and are using infrastructures on the ground. So we felt it was interesting to conclude this day by discussing the revolution that is currently undertaken by the construction industry, the architecture, engineering, and construction industry. Design for a better life. So I will tell you what is Dassault Systèmes' vision for this industry, and with a leader, iconic architect, Kengo Kuma, explain pragmatically how this vision is becoming reality today. So, first, I want to remember with you a little bit of history of the architecture, and engineering, and construction industry. What you see here on the left in the year 1440 is the beginning of the Renaissance. And you know that a significant fact during the Renaissance is that Gutenberg invented the printer, the first printer. And at the same time, first revolution came into play in the AEC industry, which is to represent the imagination of a building on a piece of paper. So Alberti, actually, he was the first to represent a perspective, a 3D perspective on a flat piece of paper. Also, he was the first who did a scientific map of a city. He printed something that was called Description Urbis Romae. So that means the map, the plan, the drawing of Rome. So, but this was still a vision in order to share with all the different stakeholders how to build this, the construction. Then we entered in the industrial era. And the best example I could find, being Parisian, is the Eiffel Tower. Why did I select this one? Because it's the first time that on the drawings, Eiffel asked his engineer to put some dimensions and all the information necessary to build the Eiffel Tower. So he asked them to perform 5,300 drawings of the Eiffel Tower even before it existed. Just as a reminder, it was already big data because Eiffel Tower has 18,000 parts. And how many rivets, you think? 2,500,000 rivets. So he decided to represent this on a drawing. So, and to conclude, it took 2 years, 2 months and 5 days to build this Eiffel Tower. So this is again was another revolution, which is to transform, let's say, a perspective drawing into a fabrication drawing. And then came the era of the computer, computer-aided design, CAD. And early in the 1990s, Frank Gehry, the famous architect, I visited many times his office, and his office was always full of I would say blocks, you know, that he was putting around, physical blocks he was using in order to sculpt what the construction would be. And then he came to the engineers and said, please build that. But when they built it, you know, it was either not constructible or it was extremely expensive. So, and at that time, he found that there was a software called CATIA who was representing shapes. Together, we figure out how to, instead of modeling with blocks, you know, the concept of the building, use a computer to model the shape. What you see here is, in fact, a Barcelona fish sculpture. And what you can see here is an ancestor of CATIA called CATIA version 3. And, well, you will hear him in a moment, but what was really magic about this revolution is that when you created the shape, you were absolutely sure that this would be constructible. So this was the beginning of the revolution, what we call design for construction. And he continued through digital mock-up. This is the Walt Disney Concert Hall. So instead of just modeling the shape, he started to model the whole digital mock-up, including the mechanical, electrical, and plumbing of the whole construction. So let's listen to Frank Gehry to tell us what he thinks about the revolution. This was in the years 1990s.
I want to guarantee that we can build that vision. And I want to guarantee that we can build it at a price that the owner can afford. The first project of significance was Bilbao. And we took our team to Bilbao. They spent a week with the 6 steel subcontractors, and they trained them how to use CATIA. And the bids came in 18% under budget, 6 separate contractors, and a 1% spread. And when I saw that, I realized we got powers here that architects don't usually have.
So 18% under budget, this is something I think we don't see very often in the construction industry. Then, of course, in the year 2010 came the area of new world of making, the new way to fabricate. You all know about 3D printing. So some of the architects, like shop architect, imagine new shapes, new structures that would not be assembled, but that would be printed by a robot in one piece. And they have erected what is now the tallest, the biggest 3D printed structure in the world. This is located in Florida. And you see a picture on the top. It's a little kiosk. And this was completely automatically manufactured from the shape that was defined inside CATIA. And, completely robotized. By the way, this is also the era for automation. It's extremely tedious, of course, to model a complete digital mock-up interactively. So Shop also created a way to automate the process. So they did create the Barclays Center in New York, which has 12,000 panels. And those 12,000 panels, with all the attachment, all the rivets, all the fasteners, were created automatically. And just to tell you an anecdote, during one of the nights, the architect came and said he wanted to change a curve on the original shape. And they generated the 12,000 panels again over 2 nights. So this was the area of automation and fabrication. Last thing is what we call the experience era. And the experience area, we see here's transformation again. So I quoted 2 examples. One of them is Frank Zehner, who is a facade maker in the United States. And of course, then we'll speak about Kengo Kuma, who also is extremely visionary in the way architecture will evolve. So let's listen first to Zehner about the dynamicity of the construction industry. Today, everything is rigid, not moving. Let's listen to what he says about that.
One of the biggest changes, I think, in the future are going to be the dynamic aspect, kinetic aspect of facades or of other constructs. It's going to be how they're going to change in shape. And 3D experience is going to allow you to predict that and know what it's going to do, know what sort of forces are going to be extended to that shape as it's moving. And it does it in such a way that it's going to open up avenues to the design community and fabrication community to do some really amazing things.
So buildings which are breathing, which are moving, which are changing shapes based on your emotion. And a second illustration is what we have installed here, the breathing sculpture that you see there, which of course is extremely dynamic, connected to nature. And I'm very proud to share this session with Kengo Kuma, because Kengo Kuma has a philosophy of the breathing material and applying material mimicking nature. So you will speak about that in a moment, so I will not spoil the whole speech, but I'm very proud to say, for example, that Kengo Kuma was awarded to build the next big museum, Oceanic Museum in French Brittany, to replace the existing one, which was a little bit not breathing enough, I would say. So this is a picture actually taken in Saint-Malo, who is hosting this new piece of architecture. So this is for the history. You need to understand that at the same time, Dassault Systems evolved, from, of course, bringing our users from 2D drawings to 3D, and you witnessed how Gary did that as well at the same time. We were the first to create a digital mock-up of an aircraft before it exists. The Boeing 777, as I said this morning, it's around 1 million parts, and each of the 1 million parts were created in the system in the year 1989. And the digital aircraft, what we call the experience twin now, existed before the aircraft was assembled. You're going to tell me what is the benefit of that? The benefit is very simple. The day you assemble the aircraft, you're sure that the assembly will go smoothly. I think there were 2 errors on the 1 million parts during the assembly process. Then we introduced life cycle management with manufacturing, maintenance, and diversity of the products. And I like to tell about this story. We invented this in the year 1999. Some people in the AC industry call it BIM, Building Information Model, but this is exactly what PLM does for all the other industries. So we're moving to the next, we have moved to the next era, designing in the age of experience. That was the theme during the whole day. So I will try to explain you now the principle behind designing a building in the context, in the 3D experience context. So you see here, sometimes it's very funny, the roads are crossing, the roads of the history, of the architecture, engineering, and construction, and the evolution of Dassault Systems' portfolio up to the 3D experience. So the revolution is underway. Now, we are together in the experience economy. Designing a product is not enough. I think you heard that during today's sessions. And we need to design holistic experiences. So what do you value the most when you're designing a holistic experience? You need to have everyone understand the experience you're developing. So you need strong collaboration. So let's look at how you can understand the whole experience. An experience starts as an imagination, as what we call upstream thinking. So ideas which are brought into 3D. Then you need to design and engineer them. You need to be able to manufacture, construct all those experiences, which are a set of connected objects. Finally, to sell them and to understand how it's used by the end user. And this is done thanks to the 3D Experience platform. You see the logo here, which allows you, like an operating system, to run all that business in a single environment. We strongly believe today that the construction industry should be connected to the city. Because when you build a building, you build it usually inside a city, so you need to take into account the citizen, you need to take into account the traffic, you need to take into account the sewing system, so you need to connect the building to the city. So there is no way you can design a building without understanding the context, which is the city. So therefore, if we have here the whole value stream that I just explained to you, the upstream thinking is about understanding the territory where you're going to build the construction. You need to understand socio-eco multi-scale studies to understand the impact on the citizen. So This is where you take the whole decisions about how the building will look like, what's going to be the impact on the citizen. Then design and engineering. So you do the master planning, the urban design, the environmental impact studies, the geology modeling above ground. You cannot build a building if you do not understand how the underground is done. Then you move to the manufacturing and construction, and finally to the sales and marketing. So all the stakeholders that are in charge of those steps need to understand the same thing. When you start the upstream thinking, the manufacturing people need immediately to understand what it is about, to be able to forecast. So the first topic is, how do you all understand the same thing? And the first language that is natural is the 3D language. It's the one that supersedes the drawing, that can be mixed. And you see here, the real world, the virtual world. So in advance, of course, you can understand how the perception of the building will be even before it exists. This was taken 5 years because that was actually erected. So that's the first thing to understand. 3D experience is 3D, and 3D is the best language to understand. Then you need to understand how the building will be used. So I have a small example here of a connected building. This building has 2,000 sensors. So let's see a day in the life of the building when it's in operation. So in this building, we can simulate, we get all the big data information that the building is emitting. For example, the consumption of the power. So you immediately see as a building owner in which areas the consumption is too low or too high compared to the cost profile that you had estimated. Same, the maintenance, how many failures do you have in the building? So instead of throwing in a lot of data, you have the 3D as a language to see how the building is going to be operated. And you can forecast what will happen a day, for example, when it's too cold or too warm. This is what we call an intelligent building. So this is really about, in the platform, being able to not only see a static view of the building, but the building in operation. This was also an example where there were some sensors detecting the human being, and this tells you which are the areas, for example. This was the lightning errors, the lightning failures during the day, either global lightning or local lightning. So this is what we call a 3D dashboard. I think you heard about this as well during the day. And finally, this is the occupancy of the building. How many people in which area of the building? So imagine that information for the owner. If he detects, for example, that there are some floors that are not occupied or that are too much occupied, it allows to completely reorganize the outfitting of the building. And to predict, this is what we call here a predictive model that allows you to predict what will happen in the future. So that's a way to understand not only the shape of the building, but also its operation. The second thing that virtual world allows you to do is to do things that you cannot do in real world. So let's look at this one. Of course, first thing is you can navigate inside the building and get to the technical documentation of each of the devices. Usually this happens with virtual glasses, so this exists today in the platform. So you pass along the building, you check the maintenance status, and you access to the documentation with your heads-up display of all the different devices in the building. Again, this is how to understand how the building is operated. And on the right side, you have also a problem on some pipes that are running under the floor. Of course, you can see where they are even before digging, because you have the experience twin, the digital twin of the building. So again, the whole topic here is how to understand. The second thing is how to imagine. How to imagine the building inside the city. So we believe that a revolution in the AEC, construction industry, is to design a building in the context of the city. With Boeing, what we started to work 20 years ago is to design a part, a wire harness, for example, in the context of the fuselage. This is exactly the same. You design a building in the context of the city. So let's look here at an example of what has been accomplished in the city of Singapore, whereby the whole city, with all the different layers of information, the traffic, the students going from a point to another, were modeled in order to make the life of the citizen better. So this is what we call 3D Experience City, that allows you to monitor not only a building, but what we call a system of systems. So 10,000 buildings together, and the different flow of information between all of them. The flow of people, how it affects the traffic. So once you have this 3D experience twin on a city, you can take the right decision to remodel, for example, a complete block, to install a new bridge, or even here in Singapore, they're thinking about moving the harbor from west of the city to the south of the city. They would immediately understand the impact. We can relax and listen to the music. And stop myself talking. Voilà. So this is the environment in which we are, which is the city modeling. The next thing is, well, when you need to establish a new building, you need to do first urban planning. So again, here a small video. So this is a reorganization of a piece of the city of Rennes in France, where they want to create a new metro line. And of course, due to this metro line, they decided to, on a given block and a given territory, to install new buildings. And for that, it's a very difficult problem to solve, because you need to optimize the citizen constraints, you need to optimize all the different networks, roads, infrastructure. So what here the 3D Experience platform is doing, it's a robot that is exploring, in fact, all the various alternatives of organization of the buildings among them, and optimizing the criteria you gave them. So instead, in construction today, like it's shown here, to have maybe 1 or 2 alternatives, the robots inside the system are generating 1,000, 2,000 alternatives with the right criteria for the human being to choose. This is what we call a cobot, which is a collaboration between a human and a robot, software robot. Of course, once you have done that, you have the principal massing of the building. You use virtual reality, actually, in order to start model the masses of the building. So here, in a very natural way, we tried here and we succeeded in escaping from modeling 3D on a flat screen. It's completely incredible still today that we're speaking about 3D, but still everything is shown on a flat screen. So when you put those glasses on top of your head, of course, you can feel. It's very difficult to see in a video like this. You need to try it yourself. But you're completely immersed in 3D, and you take the right decision instead of going back and forth between a flat screen. So this is typically a building that was completely conceived using this technology, this 3D technology, immersed technology. So I think you start to understand a little bit the revolution that is undertaken in this industry. And of course, design does not go without simulation, so you need to simulate the impact to the citizen wealth. So how many days of sun is each apartment going to have? So, you remember how to understand the experience, how to imagine the experience. The next stage is how to trade, how to collaborate. So I invited a small company in the movie here to explain us how things can be traded, so experience can be traded among the different partners.
Cecile, CTO of Oscar Company, found an interesting idea browsing the community of the company. She shares it with Carol. Carol saves useful content on her 3D drive, so she can kick off the project easily. She shares the sketches to the creative designer. Orion receives the notification and she visualizes the shared content. She directly opens CATIA V5 from the 3D Experience platform, creates the surfaces and synchronizes on the cloud. She shares the CAD product with the two engineers of the company and contacts Alan. He visualizes the 3D model with 3D Play and starts working on the internal structure. Once finished, he shares his design with the electronic engineer. Roman is working on the battery of the drone. From CATIA V5, Roman access to 3D Compass and his drive. Then he shares his design from CATIA V5. Carol, Alan and Roman review their design creation all together. They explode the design geometry and enjoy a playful experience. The drone design is ready to be printed.
So this is in 1 minute what the platform offers as collaboration environment. Or sometimes I present it to my current users and I tell them how you become a hero. How in one click you can share your design and you can trade your design in less than 1 second. So that's the power of the platform, to trade inside communities and to share the different designs on a device like an iPad, for example. And we pushed it to the limit, the platform and the collaboration. You need to understand that last year in Milano, we run what we call a hackathon, which is to have teams, architect teams, coming together and during 24 hours create, stunning experiences. And I would like to show you the results of using the collaboration platform. The teams were made of 4 people each, and during 1 day and 1 night, they performed what you will see. I will share the results with you, and I'm going to browse, the different experiments that were designed by 6 teams last year. And again, they started from scratch, 24 hours using the platform. So this, of course, is a quite interesting point of view, which is harmonizing product and nature. I will browse quite quickly. This is a more traditional way to represent an architecture. You need to know that each of the team was given a territory, and they needed to stay in that territory and to offer point of view of the buildings in 6 different points of interest. So, number 1, understand. Number 2, imagining. Number 3, trade and collaborate. By the way, this was the winning project. The winning project. You see, 24 hours in order to create this experience. Voilà. Now, last point is how do you produce? And instead of explaining you by A to Z how to produce, I wanted to have some people of CAD makers explaining you per video how from imagining the experience, they immediately are able, thanks to the platform, to produce it. Let's listen to them.
The Brock Commons Phase 1 project is the largest, or tallest hybrid mass timber project in the world. And the type of project that's never actually been built before. So when working through the simulation and the different types of sequencing options at Brock Commons, it was extremely valuable to load the Delmia simulation and test different sequences think about how materials will come into site, in what batches. You saw there that the columns came in batches of 9, and then really thinking about the drivers of the project, which is most notably the crane time. The crane is always the most important bottleneck on a site like this. So in pink and in our dummy simulation, you can see what the crane's doing at all times, and then plan sequencing of work from a safety perspective to make sure you're not doing work above, part of where the crane is installing, and doing a lot of advanced planning. The result of this was the project was 3.5 months ahead of schedule, which is a significant savings to the project, and with regards to opportunity cost of capital and interest on construction financing, the speed that the project was built was truly remarkable and a big driver for the business of the customer. And the Delmi simulation and the collaborative design and simulation was very valuable to the project.
So this is what we call an experience twin for construction. That means that the whole scheduling, the material, the whole logistics was forecast even before the battlefield, I would say, had started. So this is why you heard the gentleman saying that the delivery of the building was performed 3.5 months before schedule. That's a benefit of what we call the 3D experience twin for construction. So I went through the 4 steps: understand, imagining, trading, and producing. So I just wanted to let you know what is next. Next is automation. Automation, automation, automation. And for that, I will have a session tomorrow as well, going into detail of how we move from interactive modeling to what we call generative design, which is from the patrimony, from all the buildings you created in the past. Isn't there a way to learn what you have done and to learn to the computer how to propose you the next building? This is a whole story about generative design.